Hello, algebra students. We're going to look at these review problems, the review for the Chapter 4 test. And as we go, I'm going to talk about some of the mistakes that I've seen while grading your graded reviews. I'll try to still get through these as quick as I can, but I will look at some of those things. If the video's long and there's parts that you don't really need to hear, remember you can just zoom right past it in YouTube. Just slide the slider past those things. You can see what's being written and you'll know where you are in the video, and you can listen to the parts that you want to focus on and skip over the rest. Okay, so here we go. These first ones are graphing. So, and the first one is in vertex form. And remember, you recognize vertex form by the parentheses, right? You've got this parentheses here with something squared, and that tells you it's vertex form. And so that is the quantity inside the parentheses is squared. So we want to find the vertex first, and I'm just going to have to kind of squeeze this in. See, we need to make that smaller. Squeeze this in where we can. We look inside the parentheses for the vertex. What's ever subtracted? If there is a minus sign, which this one does have the minus sign, then the number is taken directly as the x-coordinate of the vertex. So that's 3, not negative 3, because there is a minus sign. So we don't call it negative 3. Okay, so 3, and then the y-coordinate is just this number here, which is negative 2. And that's our vertex. We also have to know a, which is the number that's multiplied out front, which in this case is negative 1. Once we know that, we're ready to graph it. We plot the vertex, which is 3, negative 2, so that's right here. And we, because a is negative 1, we're going to go down 1, right? We go over to the left 1 and down 1, which gets us to right there. We go to the right 1 and down 1, which gets us to right there. We have our 2 points, one on each side, that is, plus we also have the vertex, and we're ready to graph it. Make a nice parabola. It's not very good, but there we go. And so that's number 1. Okay, let's look at number 2. And it is not in vertex form, right? This one is in standard form. So it's a little more work. To find the vertex, we have to first find the x-coordinate of the vertex. We will call that h, and the way to find it is negative b over 2a. Of course, a is the number that's times x squared, b is the number times x, c is the constant term. So plug everything in. Negative b is actually positive 4, right? Because b is negative 4. So negative b is positive 4 over 2a. 2a is 4. So that's 1. Now to find the y-coordinate, we plug that in to the function. Okay, and the y-coordinate is called k. So k equals 2 times, and we're going to plug in the 1 for x. So 2x squared minus 4 times x, plugging in 1 for x again, plus 3. And so that is 2 times 1 squared. Well, that's 2, because 1 squared is 1. 2 times that is 2. Minus 4 plus 3. Okay, that's -2 plus 3, so that is 1. So now we have our vertex, because we already had that the x-coordinate was 1. Now we know the y-coordinate is 1, so there's the vertex. A, we have up here that A is 2, right? So we plot our vertex, 1, 1. A is +2, so it's over 1 and up 2 right there. Over 1 the other direction and up 2 right there. Plot both of those points. And then we make a nice parabola. And that's ugly, but don't want to take any more time. So that's it. Okay, so that's the graphing. One example of each. Now we've just got some good old-fashioned factoring. Okay, factor out the greatest common factor. No, factor the greatest common factor out of each expression. So you look at this and you just decide. You look at the numbers and see, is there a common factor, and what is the greatest common factor? And you also look at the variables. So with numbers, there's nothing, because there's no common factor of 5 and 2. So looking at the variables, you look at each variable. In this case, there's just one variable, and that's n. And the one with the smallest exponent, that is your greatest common factor as far as variables are concerned. So that's n. Okay, n, because it's to the first power, and that's smaller than the fourth power. So that's our greatest common factor. We can take out n. So we will write n on the outside. And what goes inside? Well, what goes inside is, you might want to do this in your head, but you divide each of those by that n to see what goes inside. Okay, so on the left we have 5n cubed, and on the right we have plus 2. And that's it. We're done. And it does want us to check. I think I can hear it saying, check me, like it wants to be checked. So you can quickly check this. Go ahead and just distribute, right? And that would, n times 5n cubed is 5n to the fourth, which is in fact what we want to get. There it is up there in our original. And then n times 2 is 2n, which is right there. So it works. So we have our answer. Okay, so the next one, we look at the numbers on this one, on number 4. We can factor out a number. In fact, it's 6, right? So then we look at the variable, and the smallest exponent on this one is the 3. Okay, x cubed. So we can take out x cubed. So what goes inside? Well, we divide each of those by 6x cubed to find out. And on the left, the 54 divided by 6 is 9. X to the fourth divided by x cubed leaves x. Okay, and then our other term inside the parentheses, 42 divided by 6 is 7. And the x's, cancel on that one. So that's it. And it's factored. You can check it quickly, multiply it back, and see if you get what it's supposed to be, and you do. Okay, so that's factoring out the greatest common factor. Then in this chapter also, in the factoring section, we did the multiplication of two binomials. So these are factors of a trinomial. When we multiply it out, we'll get that trinomial. So let's do that. Remember, you just take the 2x times 4x and then 2x times 3, and then you take negative 7 times 4x and negative 7 times 3. So you see what we get. Okay, we get 8x squared, and our middle term then is negative 6x and minus 28x, and then plus 21, because negative 3 times, or negative 7 times negative 3, positive 21. And then you always have to combine the like terms, which is these x terms. So we get 8x squared minus 34x plus 21. And that's that one. Okay, so now we'll, number 6, same thing on it. So we get 3x times 2x is 6x squared. And then 3x times negative 4, negative 12x. The other x term is the 2 times 2x, that's positive 4x. Then we have 2 times negative 4, which is negative 8. We combine our like terms, which is the middle term. That's negative 8x, right? And then we have minus 8. And that is it. Okay, so now we're going to do some factoring. Remember, there's a lot of different situations with factoring. Some are more difficult than others. So look at this first one. This one has a equals 1. Okay, the coefficient of x squared is 1. Always look at that. When that is 1, those are the easiest kind. You just look for two numbers that multiply together to make negative 10. Multiply to negative 10 and add to make the 9. Okay, so we think about our possibilities. Look at the sign. To be negative 10, it's going to have to, one of the numbers is going to have to be negative, and they need to add up to positive 9. So there it is. If we have negative 1, positive 10, that works. And what you do with those numbers in this kind of problem where a is 1, you're almost done. You just go ahead and fill in the binomial, right? X, X, and then you get the second number in each binomial from those. Okay? Minus 1 and plus 10. And that's it. It's factored. You can check it by foiling it, and hopefully it's correct, and I think it is. Okay, so let's do number 8. This one's going to the same type of situation. A is 1 again. So we need to multiply. We need numbers that multiply to negative 24. We will look at them there, and the numbers we're looking for add to make negative 2. Okay, so the numbers are close to each other. One's negative and one's positive. We want the negative one to be the larger one because they got to add to negative 2, but it's not going to be a lot larger. It's only larger by 2. The other one is positive, and so the other one must be, they must be negative 6 and 4. Okay, those will work. So those are the numbers that we put in our binomial. That is, the negative 6 goes in the first binomial, x minus 6, or the second one. It doesn't really matter which is which. And in the other binomial, x plus 4. And that's that one. All right. So now we've got some that are going to be a little harder. In fact, might be difficult to get these in the room that we have. But I think it'll be all right. So this time A is not 1. So the numbers we're looking for have to multiply to A times C, right? And A times C in this one, it's the 3 times 6, that's 18. Okay, and they have to add to the middle term, which is 19. And remember what we're going to do. Once we find those numbers, we have more work to do than the other kind. We have a couple extra steps. So we do not just plop them into the binomials like we do when A is 1. So let's find our numbers. They have to add to negative 19, but multiply to positive 18. Since they multiply to a positive number, they got to both be positive, or they could both be negative. Well, they got to add to a negative number. So they're both going to be negative, and it's negative 18, of course, and negative 1. Those do add to negative 19 and multiply to make 18. Remember how we use those now. We split the middle. That's why we found them. That's why they have to add up to negative 19 so that we can split that middle term using those numbers. Okay, so we have 3x squared. Start this a little bit higher, squeeze it all in. Split the middle term. So negative 18x and minus x and then plus 6. Okay, so now we're going to group these and factor out of each of them. You just group them in twos, and we can draw those boxes. I like that method. I think it helps you to see what's going on. The boxes are just sort of a grouping, and so we look at each of those boxes and we factor out the greatest common factor. So from the first one, both those terms in the first box have x, so we're going to factor out an x, and also in the numbers we can factor out 3. So we factor out 3x, and so what goes in the parentheses is what's left. Well, we factor 3x out of x squared, it leaves x, right? We factor 3x out of a negative 18x, that's dividing 18x by 3x. So the x's cancel, and we're going to get just negative 6. Okay, so we look at the second box. Now, it has negative x plus 6. Usually when you have that negative on the first number, or the first thing in the box, you want to factor out negative 1. Okay, so we will do that. We factor out negative 1, and we take that out. And of the first thing in the box, which is negative x, well, that leaves x. Take negative 1 out of positive 6, so that would make it negative 6, right? Now, with the reason you know it's negative 6 is because you're going to multiply this back as a check, right? And you should get what you originally had. Well, negative 1 times x is negative x. Negative 1 times negative 6 is positive 6. So it works, and that's done. Now what do we have? We do have now this common factor, which is the binomial x minus 6, and that factors out of each of these groups. We factored out of that, I shouldn't say groups, each of these products. That's a product that I just marked there. This is another product. We factor x minus 6 out of each of those products. And so when we do that, it leaves, well, and the first product has a 3x left over, and in the second product, after we factor out the x minus 6, it's minus 1, and voila, we now have it factored. And that's the answer. Okay. So that's factoring by grouping after splitting the middle. So we call that the AC, split the middle method. Don't forget, you have to split the middle. That's why we call it the split the middle method. Okay, so the next one, want our numbers to multiply to whatever we get when we take 5 times negative 12, okay, which is negative 60. And if they need to add to this middle term, negative 17. Okay, so again, one's negative and one's positive, so they make negative 60. And when we add them, we get negative 17. So the negative number is quite a bit bigger than the positive one. It's 17 larger. So yeah, negative 20 and 3 will work. Negative 20 plus 3 is negative 17. And when we multiply them together, we get negative 60. So that's how we split the middle. It shouldn't matter which order you do it in. You could put 5x squared plus 3 and plus 3x, then minus 20x, or it doesn't matter. I usually just do them in the same order that I have them written here. Okay, so that's going to be negative 20x and plus 3x minus 12. So now we have our groups. We can draw our wonderful little boxes. And in the first box, we're going to take out a 5x. Okay, 5x. I'll write it a little higher. We factor that out of 5x squared, it just leaves x. You can quickly check that, right? Multiply 5x back by x to get 5x squared. Boom, you got it right. Okay. Then we take 5x out of negative 20x, and that leaves negative 4. And again, that can be quickly checked. 5x times negative 4 is negative 20x. Great. So in the second two, we're going to take out a positive 3 this time. Because this is plus, we're not going to take out negative. You could take out negative 3, but it's probably going to be unnecessary to do that. Anytime things don't work quite right, and you have in your other term, your other product, that is, you have the negative of this thing. Whoops. Okay, what's going on here? Okay, Cami has quit working. It's not letting me draw this. I will get it though. Okay, here we go. Okay. Sorry about that. Cami can be a little temperamental sometimes. Okay. So, yeah, if we, after factoring out, if we had the negative x plus 4, instead of x minus 4, if we have negative x plus 4 in the other one, we would then change it and factor out the opposite of what we factored out the first time. So this time though, we figure we're not going to have to do that. We factor out 3, and that leaves x minus 4. We can quickly check that. 3 times x is 3x. Yes. 3 times negative 4 is negative 12. Yes. Looks good. So we have that now, and we look for our common factor. Is this binomial? Same binomial is in both of those products, right? So we factor it out. When we factor it out of the first product, it leaves the 5x. We factor out of the second product, it leaves the 3. And that's it. Okay, so we have that one factored. Yay for the AC split the middle method. Very useful. Okay, so now we're going to keep going. These next ones, when you see these squared things, 16, you know that's a perfect square. 1 is also a perfect square. So you think about the patterns, and when the just has the two terms, think that could be difference of squares. It is subtracted. It has to be subtracted, and it is. So we have difference of squares here. And remember, when you have difference of squares, the first step is, you can do this in your head, but I like to write it down. You write these down as a difference of squares. So 16x squared is 4x squared. Now we have a square there, right? We have something that's squared. Specifically, 4x is squared. And in this, as it's written, we did not have that. Yeah, this is 4x squared, but it's not written that way. It's written as 16 times the variable squared. Okay, it's not written just as something squared, but as we rewrite it, it is something is squared, specifically 4x. Now we write the other one the same way. The minus stays there, and something squared, well, 1 squared. Okay, so once you have it written that way, you just take that first the thing that's squared, the 4x, okay, and it goes here, and then we could go ahead and write it first in both binomials. And then for the other binomial, you look at the other thing that's squared, okay, and that's 1. So we put minus 1 and plus 1. Okay, the thing that's squared goes there like that. That's why I like to write it as we did here, as the difference of squares. Something squared, 4x is squared. Something is squared here, 1 is squared. So the 4x goes there, the 1 goes there, 4x goes there, the 1 goes there. Okay. It doesn't want to erase that. Probably going to erase it all later. Okay. So look at the next one. Now we see all these squared things again. 25x, yeah, 25 is a perfect square. So 25x squared is also a perfect square. 49 is a perfect square. But there's 3 terms this time. So it's not going to be difference of squares. You look at the middle term in this situation. Is the middle term double the product of whatever is squared here and whatever squared there? So let's write those down as squares. This would be 5x squared, and this one is 7 squared. So we take the 5x, and I'll just do this one over to the side this time. We take that 5x, we take it times 7, and we take that times 2. Just do it over here on somewhere in the margin where you have room. And when we multiply that together, you get 70x, right? And that is our middle term. 70x, 70x. That means it fits the pattern. Okay, if that middle term is something different, then it doesn't fit, and you can't treat it as a square. So we got it. It does work. So what we have is, I'm going to go ahead and write in here. We can write this that way. It doesn't really matter. Minus 2 times, it was the 5x times the 7. So when it fits this pattern, what this is 5x. Because the middle term is negative, it's minus 7, and then it's squared. We got our 5x from right there. Okay? That's where that 5x came from. We got our 7 from right there. That's where that 7 came from. Okay? Okay, so that's that one. And then the last one in the factoring section, we're told to solve this one. Oh, actually, number 14 is also factoring. So solving means you factor it, but this is an equation where the quadratic expression equals 0, and so we're going to solve it and find the x values that make that true. The way to do it is to factor it, and then one of the factors has to be 0. And remember, for this method to work, you have to have 0 on the right. Okay, if you're going to solve an equation like this next one, find the x-intercepts means the same thing as, solving that equation. So it won't work though until we get rid of that 4 on the right. We have to have 0 on the right. So we'll look at that in a second. But this one we need to factor. The numbers need to multiply to 28. And they have to add to negative 11. And so, again, this is one where a is 1. So we find our binomials and we're done. We can even start them out. It's going to be x and it's going to be x. And if we succeed in finding numbers that meet the criteria over here, then those are the numbers that go there. Multiply to 28, add to negative 11. Let's see, they got to both be negative, and that's going to be negative 4, whoops, and negative 11. I'm sorry, negative 7. Okay, those multiply to 28 and add to negative 11. And so they just go in here like this, and we're done. And, well, we're done factoring, sorry. Now we have to say x minus 4 equals 0, or x minus 7 equals 0. Solve each of those. Add 4 to both sides, x equals 4. And then for the other one, you add 7 to both sides, and you have x equals 7. Then we've got our solution. All right, so the next one we do the same way, except, it's equal to 4. We need it to be equal to 0. Find the x-intercepts is the same thing as solving it. Okay, just remember that. So we're going to subtract 4 from both sides. And that way we will have 0 over on the right. 3x squared plus 4x. So we have, it's going to be negative 7 and 0. And now it is set to 0, so we can factor this. We got to use the AC method on this, or you could use guess and check and just kind of play with it. I like the AC method. So a times c is negative 21. So our numbers have to multiply to negative 21 they have to add to 4, yeah, to 4. So our middle term, so we can split our middle term. And that's going to be the positive 7 and negative 3. So we write that in. We split that middle. 3x squared. I'm going to have to scroll down so I have a little more room to write. Okay. Let's see. So let's go plus 7x minus 3x, and then minus 7 equals 0. We split the middle term. Now we do our fancy factoring of each of those pairs. And the first one, we can just take out x, right? Because the numbers, we have 3 and 7. They don't have any common factors. So we take x out of that first term, it leaves 3x. We take it out of the second term, it just leaves the plus 7. Looks interesting, 3x and 7. Looks like it might work. Now we do have to factor out a negative 3. Sorry. Negative 1 out of those last two. So out of this box, we just factor out negative 1. Okay, and you can see that because we have a negative here. We also see it because as it is, it doesn't quite match. They're negative in the box, and the one we need is positive. So we factor out negative 1 like that, and we have 3x plus 7 inside. We can check that by multiplying back real quickly. Negative 1 times 3x, negative 3x, negative 1 times 7, negative 7. Good. So we've got it. We factor out the 3x plus 7 from each of those terms, from each of those products, I should say. And from the first product, which is here, what's left is x, right? From the second product, which is here, after we factor that quantity out of 3x, that is the 3x plus 7, what's left is minus 1. And that's equal to 0. So I'll write it over here. 3x plus 7 equals 0, or x minus 1 equals 0. So we solve that. We have 3x equals negative 7. Divide both sides by 3, and that leaves x equals negative 7/3. Oh, the other one is quick to solve. Add 1 to both sides, right? X equals 1, and you're done. Fix that. Make that a little neater. There we go. Okay. We could plug those into the original equation and check them. I'll check the 1 really quick. The negative 7/3 a little harder to check. You had to square it and all that. So we won't check that one, but it should work. So put in 1, well, you get 3 plus 4 would be 7, then minus 3 would be 4. Okay, so it works. 1 works. We didn't try the negative 7/3. Pretty sure it works too. Okay, so now we're done with factoring. We're going to be doing the simplifying, and then last thing is the quadratic formula. So remember, when you simplify these, use that cake method. So here goes on the first one. Now, one thing I've noticed is sometimes you guys will use something that's not a prime. And this, for the cake method to work, what you divide this by has to be a prime number. If it's not, you could sort of use a modified cake method and split that up into 2 primes. But, you know, we're not going to talk about that. we're just going to use all primes. Okay, so 2, and that leaves 66. And let's just keep using 2 as long as we can. Get 33. Oh, can't use 2 there, but we can use 3. And you get 11. And once you do that, everything here is a prime, right? Everything's a prime. That's the way it has to be. If you have numbers there that aren't primes, you don't really have the prime factorization. So I saw this happen on several of you guys' graded reviews. You might have a 5 or a 9 or something sitting in this prime factorization that's outside the cake. You know, this is it. When you get done, that's your prime factorization. All those numbers need to be primes. Okay, if they're not, you should have used a different number. You should have used a prime. So we've got it, and now we look for the pairs, the groups of 2, we could say, and we just have this one, but that means the 2 comes outside the radical. And now what goes inside the radical? Well, everything else, which is 3 times 11, which is 33. And that is it. I have something wrong here. I think I need to check this. Oh, yes, I do. Made a mistake. Sorry. We'll have to fix this. Sorry about the extra time that takes. I might edit it and fix it, but I don't think so. Just one of those things. So I made a mistake. 112 divided by 2 is not 66. So let's get rid of this. Hate it when that happens. Okay, try again. So what we have here is 112. We're going to divide by 2. It's 56. Okay, divide that by 2, you get 28. Divide that by 2, you get 14. Divide that by 2, you get 7. That's our prime factorization. So, what we have outside the radical is a couple of 2's. Okay, since we have 2 groups of 2's actually. So each one of those is a 2 outside the radical. So outside we have this, 2 times 2. Inside we have what's left, which is 7. So you have 2 times 2 outside is 4, times the square root is 7. And that is it. Okay. Okay, so let's keep going. So this next one, well, the -3 is outside. And that's no big deal. That's just going to stay outside. We have to deal with the 150. So let's do that. We do the cake. We got 275. Remember, these always have to be primes. Don't put a 25 here, because that's not a prime. So we could put 5 there, and then that's 15, and then do 5 again, and you get 3. Okay, so we have a pair there. That's the 5. Okay, so the 5 comes out. We have room to write it right here, so that's where we'll write it. That's the only thing that comes out. Inside you have 2 and 3. 2 times 3. And so that inside is 6. So you have 5 times the square root of 6. But that's actually, I wrote this a little bit not very good. That is the square root of 150, but of course our negative 3 is still there as well, right, on the outside. So you have negative 3 times that. Well, that's negative 15 then, times the square root of 6, and that is our answer. Okay, next one has this negative. So this is where you're going to have an I. If there's a negative inside the radical, and I will write it down this time, you don't necessarily always have to write this, but you're splitting that radical up into the square root of negative 1 times the square root of 80. And now the square root of negative 1 is I. By definition, that's what it is. And you have the square root of 80. So now we can simplify this. There is no negative under the square root anymore, okay? Because we split it up into the square root of negative 1 into this other radical, and we simplified that to I. And now we need to simplify the square root of 80, which we'll do over here. We'll do our prime factorization. Get 2, 40. That gives us 20. Divide that by 2 as well. Gives us 10. Divide that by 2 as well. And we get 5. So we have our prime factorization. And we have 2 pairs here of 2's. So each of those is a 2 that comes outside. Let's write that underneath here, and just remember our I is still there, but outside we have 2 times 2 times I. We can write it that way because the I is still there, right? That's just that. And inside the radical is just 5. So 2 times 2 on the outside is 4. The I is still there, and that's it. Okay? 4I times the square root of 5. Okay, now this next one is one you guys made a lot of mistakes on this. I think, though, you'll be fine if you just realize this is a minus sign. So just because you see a bunch of parentheses doesn't mean you start multiplying. Okay, do not multiply when this is a subtraction problem. This is a complex number. It's got a real part and an imaginary part. This is a complex number. Has a real part, this, and it has an imaginary part, which is that. What we want to do with those two complex numbers is we want to subtract them. Okay, take the first one minus the second one. And the way we do that is we operate on the real parts. We do that operation of subtraction on the real part, and we also do it on the imaginary part, and we're left with another complex number. So you just take the negative 3 minus negative 7. I would rather go ahead and distribute that minus sign here before we start. So we'll have negative 3 minus 6i, and then that's minus a negative 7, right? Minus negative 7, which is plus 7. And then minus negative 5i, that's plus 5i. Whoops. So now we got negative 3 plus 7 is 4. Negative 6i plus 5i, negative I, and we're done. Okay, 4 minus I. Okay. So we got a few more of these operations on complex numbers. This is a multiplication. Now we don't have any on this that are actual FOIL. Maybe we'll do one. I think you guys are okay on those though. So this one, simply 6i squared. Well, you know, that's 6i times 6i. So just 6 times 6 is 36, and I times I is I squared. Another thing to remember, I squared is -1. So anytime you have I squared, you just replace it with -1. It's 36 times -1. You should never look at your answer when you're done and see I squared. Okay, that should not be there. You are not done if you see I squared. Okay, because you should be simplified to -1. So 36 times -1 is -36. And that's it for that one. Okay, what we didn't have is a simple FOIL. I think you guys have seen plenty of those. And actually, we will do a FOIL on the division. So I don't think I will add any after all, but you do have to be able to do that. But the video is going to be pretty long as it is. So how do you do division? Remember, you multiply numerator and denominator by the conjugate of the denominator. The conjugate will be the complex number that when we multiply it by the denominator, we will not have a term with I. The imaginary part will be gone. And that number is just, in this case, 2 minus 10i. Okay, so it's because that was plus, we use minus. If that had been minus in the denominator, we would make it plus in our conjugate. So we multiply numerator and denominator times that. Okay, so the numerator will be just multiplying, it will be distributing. So 4i times 2 gives us 8i. And then 4i times -10i gives us a -40. Whoops. Boy, this is messing up. Sorry about that. -40i squared, right? But we're not going to leave it that way because that's I squared. Okay, I squared is -1. So I think we'll go ahead and change it in the next step though. So the denominator, we FOIL this. 2 times 2 is 4. In the middle term, we have the 2 times -10i, -20i. But we also have 10i times 2. That's positive 20i. So that goes away. It cancels out. You can write it down if you want, but it will cancel. So I'm not going to write it down. It's -20i plus positive 20i. That's 0i, which was the whole reason we picked that as the conjugate. Okay, so there is no I term. And then you take the 10i times negative 10i. That is it's negative, sorry, negative 100 I squared. And I'm going to get rid of my underlines though first. Negative 100 I squared. And we're not going to leave I squared in there, so that numerator becomes 8i. The I squared is negative 1, so that will make it negative 40, right? 40 times negative 1 is negative 40. We're subtracting negative 40, so that's the same as adding 40. And then the denominator, we have 4 minus 100i squared. Well, 100i squared is negative 100, so it's 4 minus negative 100, which is 4 plus 100. Okay, so that we're almost done. We simplify, and on the numerator we're going to switch the order because we put the real part first. So that's 40 plus 8i. Sorry about that. And in the denominator we just are going to combine that. It's 104. Now I'm kind of short on space here, but I do have enough room to do what I need to do for the last step. Which is, we have to see if we can reduce this, and it has to be a number that goes into all three numbers, 40 and 8 and 104. And if you look at it, 8 goes into all of them. Okay, so 40 divided by 8, that's 5. Okay, 8 divided by 8 is 1, so that's just 1i. And 104 divided by 8 is 13. And that is our answer. Now on these, when they don't have a radical, we do split them up. And don't like this. I didn't plan very well. I'm going to write on the top of the next page. I won't count it wrong if you leave it like that, but we generally split them when they don't have a radical into 5/13 plus 1/13 times I. Okay, write it like that. Or you could write I over 13 for the second one. Okay. Or it's actually okay with me if you leave it like this. I'm not going to be real strict on that. Okay. So now only thing left is the quadratic formula. This one you guys might have noticed, it's the same it's the same page used for the graded review, but I crossed out most of them. So these first two I think you did on the graded review. So I'll skip those. And we're going to, no wait, so that may not be right. Maybe you didn't do, you didn't do the first one. You did the second one, and then you did numbers 3 and 4. So we will do number 1 because you didn't do it. So we just plug everything in. I'm going to zoom in on this a little bit more so I have more room right under it. Here we go. Sorry about that. Okay. So, quadratic formula. Negative b, and I'm not even going to write down the quadratic formula. You guys know it, right? you take negative b, so that's negative 2 plus or minus square root of b squared minus 4ac. B squared is 4 minus 4 times a, which is 1, times c, which is negative 63, all over 2a, and 2a is 2. So, see if I can write it neater this time. Negative 2 plus or minus square root of 4. Okay, of course we have minus and negative, right? Always look at that. Your product here will be negative, so be careful with all the signs. Really, on these quadratic formula problems, you guys miss these a lot, and it's usually just a math error somewhere. You subtract when you should add or something. So try to get these right on the test. It will help a lot. So this is going to be positive because we're subtracting a negative, and when you multiply it out, you get 252, so it's plus 252. That's over 2. And this one comes out nice to a nice perfect square, 256 under the radical, and that's 16. So you got negative 2 plus or minus 16 over 2. So you have to go ahead and get the two answers here, right? When it comes out nice, when it's a perfect square like that, we're going to have negative 2 plus 16 over 2. And we're also going to have negative 2 minus 16 over 2. So the first one is 14 over 2, which is 7. And then this negative 18 over 2, which is negative 9. So that is your answers. Okay? So we're not going to do the others on this page. Those were on you guys did them on the graded review. So on the next page, though, we're going to do some of these. The first 4 you did not do. Let's see. I'm going to do, probably won't do all of those. I'll do the first one. These are just for, to watch if you want to, and you can speed through these. Just I'll try to give you some tips on trying to avoid errors. So, negative b, that's negative 5, plus or minus square root of b squared is 25, minus 4ac. 4 times a is 1, c is negative 36, all over 2a, which is 2. Okay, so that's negative 5 plus or minus, what's this under the radical? 25, what's your signs? Minus and negative, so it's going to be plus 4 times 36, 144 over 2, and this gives us square root of 169, which is another perfect square, which is fun. And so that's 13, right? Negative 5 plus or minus 13 over 2. And so that comes out to the two answers, 4 or negative 9, I believe is what you're going to get when you simplify that. Okay, let's look at the next. Let's see. The next one. I believe, yeah, we'll go ahead and do this one. Okay. Now this one, you're going to end up with a negative under the radical, so that's a good one to do. So you get negative b. Negative b this time is positive 6, right? Plus or minus square root of b squared is 36 minus 4ac. 4 times 2 times 8. So you have a big number that you're subtracting there, and we see we're going to get a negative under the radical. On the denominator, 2a is 4. Okay, so we get 6 plus or minus square root of 36 minus 64. Okay, all over 4. So that's 6 plus or minus. What we get underneath there is 36 minus 64 is negative 28. All over 4. So we've got to deal with that negative 28. And you can write it, if you want to, square root of negative 1 times square root of 28. Or you can just know that, okay, it's going to be I times the square root of 28. So that's what that is. Okay, when you get this negative, or square root of negative 28, if you want to, just go straight to here. Okay, if you can make sense of it, and if that's clear to you, then do it that way. It's fine. So we have to cake that 28. Some of these, after doing a few problems, you might just remember what they are. I don't really remember this, although I probably should. Okay, we're going to do 2 again. Yep, we get 7. So there's a pair of 2's there, so out front there's a 2. The I is still there, and out front there's a 2. We'll put it on this side of the I. Inside the radical, there's a 7, and that's it. So we get 6 plus or minus 2i times the square root of 7, and that's all over 4. We do have to simplify that because there is a number that divides into all 3. We got 6, we got 2, we got 4. 2 goes into all of those. So the 6 divided by 2 is 3. 2 divided by 2 is just 1. We could write 1i square root of 7, or just I times the square root of 7. And 4 divided by 2 is 2. So that's the denominator. You don't have to split it up into two into the two possibilities or the two parts, but you can leave it. When you have an I, you can just leave it like this. Now I want to mention I did something just for fun. I went ahead and wrote this out: 3/2 plus square root of 7 divided by 2 times I, like that. Okay, I split it up, and then I also had 3/2 minus that, and those are my solutions. If I really wrote them all out completely in as complex numbers with a real part and an imaginary part. And then I'm not going to do this on the video. I think it's kind of cool. You guys would think it's boring. I didn't do both of them, but I took this first one. I plugged it in for m in the original equation. I actually squared that mess, which is, just foiling it out. And that was I squared it so I could do the 2m squared. I took this whole thing. That's what we're saying m is, right? We solved for m and we got that. So I plugged it in for m. I did this whole thing to make sure it equaled 0. Now to do that, I had to approximate the square root of 7, because that's an irrational number. You can't get it exactly. I rounded it off to 2 decimal places, 2 or 3 decimal places, and I checked it, and after checking it, it came out to 0.02 equals 0. which is basically pretty good assurance that it is correct because the rounding, see, we're not going to get exactly 0 equals 0 when we plug that in. So I thought that was kind of fun. Usually you do not do that. It's very tedious. Just did it this time. Okay, so there's our answers. Again, we write it like this. Okay, so number 7 is another one that comes out with an I. I don't think I'm not gonna do that one, but I will go ahead and do number 8. And that one is the other one that you guys did not do for the graded review. So we have using the quadratic formula, negative b, so that's negative 5, plus or minus the square root b squared is 25, minus 4ac. A is 2, c is negative 17. All over 2a, which is 4. Okay, so what do we get? Okay, that's 25. So this is minus a negative, so it is going to be plus. 4 times 2 times negative 17 comes out to 136. So you get negative 5 plus or minus. So 25 plus 136 is 161. Okay, and then that's divided by 4. Okay, so we have to see, we have to cake this 161. Okay, so you try numbers, 3 will not go into it, 5 won't go into it, of course 2 won't go into it, so you just keep trying primes. So we're going to take 7. I'm actually just going to let you guys try that. Try all the numbers. See if anything divides into it. So it turns out 7 goes in, and that's 23. And then 23, of course, is a prime. So you're done. And those are there's no pairs there. Our prime factorization is complete. Just 7 and 23. Remember what you're after here is a prime factorization. You want this to be completely factored in to nothing but primes, and this one is. And so the 7 and the 23 would go together inside the radical. Nothing comes out because there's no pairs. And when you put them in there, it's just going to be 161 again. So it's done. Again, I'm okay with you leaving this like this. It's also more customary, I think, to split this one up. But it's okay either way. So, and by mean, you can write it as minus 5 plus square root of 161. I mean, split, write the two solutions like this, but you don't have to. And we haven't been doing that. Okay? So you can if you want to. So you could write this and you could write it in brackets, like that's the solution set. But this is the way we've usually been, just leaving it like that. Okay, so that's all we're going to do. I hope that helped. You could find some parts of it anyway as you scan through. Good luck on the test. Remember, get your notes in good shape. You want to be able to find everything quickly in your notes, so get familiar with your notes, know where everything is. Write down little helps, like next to your prime factor example, write something like, must be prime, because every number you divide by has to be a prime number. So anyway, get those notes in good shape, and good luck on the test.